Okay, so today's demonstration is going to be on deep ocean currents. For this demonstration, I'll be using hot water, room temperature water, and cold water. The dyes I'm going to use to represent cold water is blue dye, and the color to represent hot water is the red dye. The room temperature will be as is. I'll also be using a dropper, and you'll see what I'll use that for in a moment. So first, to demonstrate one of the factors influencing ocean currents, I'm going to dye the water, and then I'm going to put them in the room temperature water, and we're going to see what happens. So do that now. Couple drops. Okay, I'm just going to give that a stir. Okay, so first I'll start off with the cold water and drop it into the room temperature water, and we will see what happens.
Okay, so for this part I basically added more of the blue food colouring to really contrast the colour. You'll notice as I'm dropping in the blue cold water that it is sinking towards the bottom. As it's doing this, we will want to think about what properties of cold water are making it sink to the bottom. And as we're seeing this, we should start to think about what we think the red hot water is going to do.
So as you can see, there is a lot more blue color towards the bottom of the container. This is because cold water is more dense than warm water. So now what we're going to do is we're going to add the hot water, and we're going to see how it differs to the cold.
Okay, so basically for this part I just repeated what I did with the blue cold water with the hot red water. So just observe what you see as the red water is put into the middle tub. Notice where most of the red colouring is gathering. Notice how it's moving. At this point it's very obvious what's happening with the red hot water.
Okay, so as you can now see, the red hot water is staying towards the top of the surface. This is because hot water is a lot less dense than cold water, so it remains closer to the surface. So the gradient we see here is dark blue at the bottom, representing the cold, deep waters of the ocean, the middle layer representing our room temperature water, and then the surface is a warmer temperature due to factors such as the sun and direct heat from the sun. So in summary, for this part of the demonstration, we can see that the colder the water is, the lower it goes to the bottom, and the warmer it is, the closer it goes to the top. Now, there's one more other factor that influences this process, which is salinity, and that aspect of it actually makes the water move, and that's when we get deep ocean currents.
Okay, so for this second part we basically have two compartments, one with 0% salt and the other with salt. Now, this is what happens when we take away the divider. What you're now witnessing is an internal wave. Now, that internal wave is caused by the dense, salty water. Now, what that internal wave is representing is our deep ocean current. Notice how that internal wave is actually not affecting the surface, which is essentially one of the main factors of a ocean current, deep ocean current. Now, what we're doing now is mixing the salty and no salt water to create an intermediate kind of solution. Once you remove the divider, you get another internal wave. And once it settles, you'll see that you now have 3 layers. Okay. If you actually place your finger inside, you'll notice the temperature goes from warm to cold. Okay, so there you have it, guys. 2 factors affecting deep ocean currents: temperature and ocean salinity.